let's get the foundation, then we go to the problem. So we talk about the multiplication rule. Okay, so basically, if it's going to be just a number of the order pairs, if you think about it as a sets. So if two sets are given to you, then you form the set of all order pairs A cross B. So the number of the elements is going to be the number of the elements in A times the B. So we change it into this counting format is something would be given to you. You want to do a procedure that you have to break it into parts. So if you break it into the parts, so you have to do the part 1 and 1 base, N2, N3, and to the Nk. It's like you have different sets, A1, A2, A3 up to the Ak. So the whole procedure can be done in, the multiplication, the product of all the number of the base. So that's what's the product rule. I'll give you a couple of examples. And that's like a license plate. Now, and we end up with the notion of the factorials. Now what we're going to do, we are going to use it in order to define what is going to be the permutations. Okay, sometimes you'll be given a group of the objects and you want to order them. You want to list them. So if you want to list them in a row, so there are different possibilities. This type of possibility is going to be called a permutations. Okay, a permutation is a function. It's a kind of one-to-one function, we call it, but we don't use the function notation. Okay, so what is going to be, we just continue, it's in 9.2. So we want to know what's going to be the definition of a permutation. Permutations. In algebraically, if you have given a set of n elements, you want to know how many functions can you define from that set into itself. And those functions with a special property that we call them a one-to-one function. But in this form, we are going to think about the arrangement of the objects. So a permutation, switching if you like, a permutation of a set of objects, is just an ordering, is a function. Okay, it's going to be a listing and ordering of the given object, ordering of the objects in a row. Okay, this is the meaning of permutations. So if you be given n numbers, okay, so for any given n, okay, any integers n greater than or equal to 1. So you have the list of the n objects. You want to know how many ways you can arrange them in a row. Okay, if you go to in your row, so you want to put them into different boxes if you like. Okay, so you are going to have the n boxes here. Okay, and seats, boxes. Okay, so these are going to be, okay, you think about it that this is going to be n boxes that we are going to have over here. Okay, and you have n elements or n letters. So if you want to fill up the first one, you have n choices for the first one. So you have n choices to drop one in the first box. Then you are done with the first box. So it's going to be one box less and one numbers less, if you like, or letters. So when you get to the second one, you have n-1 choices for this one. Okay, because you already picked one here. Okay, so we did the first one. So when we get to the second one, the number of the choices are going to be n-1. Okay, so that's going to be for the first one, and then we get a second one. So then when you're done with this one, you go to the next one. So the number of the choices would be 1 down. It's going to be n-3. Okay, and you just keep going. When you keep going, when you get to this one, so you will be, so n-1, n-3, that. So in this case, you are going to have only 2 choices. And when we get to the last one, you are going to have only 1 choices. Okay, so we start with the n choice, n-1, n-1, that's n-2. Okay, n minus 2, n minus 3 up to the 2 times 1. So by the product rule, the total number is going to be, you see you have n choices for the first one, n minus 1 for the second one, n minus 2. So if you put them together, that give you 2 times 1, which is going to be equal to the n factorial. Okay, so the number of the ways then you can arrange n objects in a row is going to be n factorial. Okay, so we call it the number of the permutation. So the number of, and that is going to be a method that we just apply to use various formulas of related to the permutations. Okay, the number of the ways to form, okay, to form an ordered list or permutation, ordered list of n objects and distinct, okay, and distinct elements, objects. Elements is going to be just n factorial. Okay, the number of the ways that we can put them in a row. Sometimes this is going to be a permutation of n elements. But sometimes you may be interested in some special one of these groups that we're going to have. Okay, the way we are going to order it. In this case, we order one in each box. So in general, we have something, this method can be combined to get something that we call it arrangement formula or arrangement principles, if you like, okay? So let's compare with this one. What is going to be arrangement rules, if you like, or principle. So what's going to be this one? So the number of the ways, the number of ways, the number of ways to form, number of the ways to form an, okay, an ordered list. Ordered list of this time are distinct. You may not be interested in all of them, just some of them. Okay, so you have n elements, but you would like to order only r of those elements. The number of the ways to form an ordered list of r distinct elements or objects, elements drawn, okay, drawn from a set of n elements. An element is going to be denoted by, is going to be denoted by, this is going to be a notation, P of n comma r. P stands for the permutation. N is going to be the total number of the elements that we have. R is those numbers that you are going to be interested in. So this is going to be a permutation of, okay, R arrangement of the n objects, if you like, P of n R out of n, if you like. And now, let's see what's going to be the formula this time. Okay, any question? So what is going to be the difference between this one and the other one? You see, in this part, you are going to have n objects, and you are going to have your, what's that? And this is going to be the boxes that we talked about it before. You see, it's going to be the boxes that we have. 1, okay, 2, 3. So we get the boxes. We go up to the R boxes are the one that's going to be here. And then we continue. You see, you are going to continue to get to the n boxes, if you like. Okay, these are going to be 1, Okay, so this is going to be the case. So what we did, this is going to be just the n elements that you have. Okay, you have the n boxes all together. This is going to be n boxes or n seats. So what would you like to do? You are going to use only R of these. Okay, you want to find what? Order list of the R distinct elements. So what you're going to do, you are going to divide this one into two groups. So for the first group, these are going to be R boxes. Okay, so this is going to be the first R boxes that you're going to use. Okay, this is going to be the R, and this is going to be your leftover. So the leftover is going to be n minus R, if you like. Okay, so when you want to arrange it, again, the choices that you're going to have for the first one, you have to fill up this one. So you have n choices for this one. Then we go to the next one. You are going to have n minus 1 choice. Okay, then you are going to have n minus 2 choice. Okay, and you just continue. You just continue to get to this last one. Okay, when you want to get to this last one. Okay, so what is going to be the case? So it's going to be n minus. Okay, n minus. So remember R of this. So it's like, this is like n minus 0, n minus 0, 1, 2, 3, up to the. So when you get to the up to the R, it's going to be n minus, okay, it's going to be n minus R minus 1. You see, this is going to be the cases that we're going to have. Okay, so it's going to be, the first case is going to be 1, 2, 3, 4, 5, 6, up to the R that you're going to have over here. Okay, and then you continue, that take you to the last one, which is going to be 1. But you are going to be interested in this form only. So as you can see, the number of the ways that you can pick this one is going to be P of n comma R is going to be by the product rule. By the product rule, we have the n choices here. It's going to be n minus 1. Okay, n minus 1. And it's going to be n minus 2 up to the R, which is going to be up to the n minus, this is it, minus R minus 1, which is going to be minus R plus 1. See, in this case, that gives you the permutation of, okay, the R permutation, we call it R permutation from the, okay, from the M elements, if you like. So this is a nice version, and we can do this one for various parts, especially when some that we use in a statistic. But if you like to write this one in terms of the factorials, okay, so if you want to go up to the n factorial over here, you see, if you want to go up to the n factorial, there are some that's going to be missing here because you have to continue, you see. Here it's going to be n minus 1, 2, 3, 4, 5, 6, etc. to get to the 2 and the 1. So if you like to make it as a nice formula, you have to create the leftovers. Okay, note that. So what is going to be the result? We already got P of n comma R is going to be equal to, what I'm going to do, I'm going to multiply by the leftover. You see this blue one here, multiply by the leftover, and then I have to divide by those leftovers. So so far what we got is, so I got a quotient bar here, quotient bar here. So we already got the n times n minus 1 times n minus 2 up to the n minus R plus 1. Okay, then we have to continue. We have to continue to get to the missing one. You see, the missing one is n minus R of these, if you like, that you get, you get over there. So if you multiply it, okay, if you multiply the top and the bottom one that we have, you have to subtract these n. Okay, this is n minus, you see, you just keep going. This is n minus R minus 1. This is going to be n minus R minus 2, you see. I write a couple of them for you. it's going to be n minus r minus 2. You see, and you just continue. It's going to be n minus r minus 3, and just keep going to get to the 2 and 1 if you like. So the bottom one, so what is going to be the bottom? You do the same thing in the bottom. Okay, you have to divide it by n minus, okay, this is it. It's going to be n minus r minus 2, the same thing. Okay, they get the 2 and the 1. So the top one would give you the n factorial. You see, that would be the formula that you memorize it to use it. It is going to be n factorial on the top, and then the bottom would be n minus 1 factorial. N minus 1 factorial. You know that this is going to be product up to the n minus r factorial. If you put them together, so that would give you the formula that we are going to have. Okay, so this is going to be the permutation of r permutation of the, or r arrangement of the given sets of n elements. And if you put r equal to the n, this is the one that we did it before. So that gives you just the permutation of n elements. So the top would be n factorial, the bottom one would be 0 factorial, and 0 factorial is 1. So that gives you n factorial over 1. So that gives you n factorial. And I already talked about it. Okay, so even you don't need any formula really. In practice, these operations that I did, I just proved it so that you can see it. You can use this one to answer the question, and this method is a very good one for various problems of the accounting problem. But there are some problems in your book regarding this formula, so you have to know it. But on the test, you have different options. Okay, original one or this one here. Okay, so standard examples, the one that we're going to be interested in that factorial one. Okay, to give you a couple of examples, to give you one on this quiz and one on the final. In your book, there are some algebraic one we are not interested in, some identity. I do one of them for you. But this is a typical problem. Look at this one. A baseball team has has 24 man roster. Okay, the people. So the total number is 24. They want to pick members for the batting. So we want to know how many ways. Okay, how many different ways? How many different ways there to choose or to select a 9 man batting order. Okay, so you want to choose the arrangement 9 out of 24. There are two ways to do it. One is just the direct formula that we talk about it, or just make up this one yourself. Okay, I'll just do both of them for you. You see, if you don't know the formula, it doesn't matter. So what you would like to do is you would like to get the arrangement, a selection of what? A selection of a team of 9. You see, this is going to be the case. So that's going to be your team, 9 men. So you have 24 people in the team. So the first choice for the first one is going to be 24 choices. Okay, so the second one would have a 23 choices, and that you just keep going. 22 choices to get to the 9. To get to the 9, this would be 16. So the total number of choices for the rule is going to be 24 times 23 times 22. Okay, just keep going. Times it by 16. Okay, so that gives you the total number. It's going to be a big number. Okay, you can use your calculator to find it, or just if you write the arrangement, it's going to be an easy one. We accept it. We don't want you to evaluate it, but if you are interested in, if you use your calculator, the calculator give you the result in exponential form and in scientific format. I just write it down, so don't be surprised if they give you something like 4.74 times it by 10 to the 11. Okay, that give you exponent 11. So you find out that this is going to be the result. Okay, this is one way to do it. So that's a method 1, just the actual action. But the method 2 is just the standard that we talk about it, and the formula. So in this case, you have the total number of the 24 objects, if you like, and you want to get the arrangement, a permutation, including 9 people. So the answer is going to be, you see, permutation of 9 out of 24. So that is going to be the case. So just substitute the formula. Remember, P of n all of n is going to be, what's that? N factorial, n minus r factorial. You just substitute. So 24, 9. So that gives us a 24 factorial. And it's going to be 24 minus 9 factorial. Okay, so the top would be 24 factorial, and the bottom one, 9 out of 24, would be 15 factorial. You simplify it, we talk about it. We can stop as with the one that you are going to be interested in. So 24 factorial can be written as a 15 factorial times the leftover, which is going to be 16, 17, up to the 24. So divided by 15 factorial. So 15 factorial and 15 factorial would cancel out. Okay, this is the way we simplify it. So P of 24 and 9 would be simply the product of, okay, 16, that's it, 16, 17, 18, okay, up to the 24. On the test, it's going to be, we accept that. If it's going to be easy number, just multiply it. And sometimes the number is important to have it, you're going to do it. Otherwise, the one that we're going to have is not going to be a big one. But anyway, you can use your calculator to get the numbers. Okay, so this is one way to do it. Any question? Now, the one that we have are going to be mainly related to the combination of letter of alphabets. Okay, so we would start with the next one. Read it carefully. These problems were easy, but you have to read it carefully to not to miss anything. So, any question on this one? I need more space, so I go to the next page. You have a couple of them in your practice one that we will post, and this is one of them. We want to know how many different ways, how many different ways, how many different ways are there? Okay, are there to rearranged? Okay, rearranged. Rearrange the letters. Okay, the letters in the word. In the word, this one. Gorland, that's it. This is going to be the case. Okay, so this is it. So in this problem, all the letters are distinct. When it's going to be repetition, the formula would be different. But we go with the distinct here. So you're going to count the number of the letters that you have. Okay, so in this case, you have 1, 2, 3, 4, 5, 6, 7, 8. Since they are distinct, it's like having what? 8 different objects. So if you have 8 different objects and you want to arrange it, it's like you have 8 different objects and 8 boxes. So we want to put one in each other. Okay, so that gives you that factorial that we talked about it. Okay, so the solution is going to be, solution is, this is it, you note that. So note that there are, okay, there are n equal to the 8 different letters. Okay, different letters in the word, in the given word. So the number of the ways is going to be, so it's going to be the same as the number of the, okay, is the number of the permutation. So the number of the ways, just 8 factorial. You know, for the first box, again, you see you have 8 choices for the first one. You see, if you want to just the one that I talk about, 8 choice for the first one, then 7 choice for the second one, 6 choice, 5, 4, 3, 2, 1, which is the same as 8 factorial. Okay, and the 8 factorial with your calculator, or it's going to be 40,320. So that gives the result. Okay, so it's a permutation of an object, which is n factorial. Okay, so if you like it, this is going to be the case. I like to know to rearrange it so that I repeat that formula. Note that P of 8, 8 is just 8 factorial. Okay, so not a big deal. Without the formula, again, you can do it. Question? Now, sometimes they change it a little bit. It's the version that you have in your book, in your assignment. Sometimes they put some restriction on it. Okay, they like to start with a specific, letter, if you like, or a combination. So let's see what's going to be this one. So for this one, we are going to use 2 different formats. The first one is we want to know how many ways. Okay, how many ways? How many ways can the letters? Can the letters in the word? Letters in the word computer. Okay, computer. Be arranged in a row. Be arranged in a row. The words are all different, okay, distinct. It's going to be 1, 2, 3, 4, 5, 6, 7, 8 again. So it's going to be 8 factorial for the first one. It's like the previous one. But they changed it a little bit for the second part. Look at this one. For the second part, they ask how many. Okay, they ask for how many ways. How many ways can the letter? Can the letters in the word? The given word, computer. be arranged. Okay, be arranged if the letters, okay, the letters CO, okay, letters CO, okay, must be together if you like, okay. So how many ways can the letters in the word computer be arranged so that if the letters CO must be, okay, must be together, must be remained and next to each other, next to each other. Okay, so for the second part, we have okay, you have this restriction, if you like, to get these numbers done. Okay, the first one, no restriction. You have 8 objects. You want to arrange it in a row, so the result would be 8 factorial for the first one. Okay, as we did it for the other one. So the solution is going to be the first one. We have 8 different letters. Okay, in the word computer. So there are okay, there are n equal to the 8 different letters. Okay, different letters in the word. Okay, in the word computer. And so 8 factorial, which is 40,320 is the number of the arrangement. Is the number of permutations or arrangement. Okay, number of the arrangement of letters. So that would be the part 1. Now part 2, the situation is different. You would like the CO to be together. So what we can do is we put the CO together, we put them in the box. You see, this is the problem that I'm going to explain or we're going to have is going to be of this format. That's why we want to check this one first and then we go to our problem. Okay, so for the second part, so what you are going to be interested in, you would like to have the CO together. So you put the CO together. You see, that's going to be the one. And you put it in the box. So we already got 8 letters. Okay, we got 8 letters. So we put 2 together here. So we put 2 together. So the leftover is going to be what? So that was the case. So we are going to have, this is going to be 1, 2, 3, 4, 5. Okay, and the 6. Or the letters that we're going to have. Okay, because we already got 8 letters here. So 2 out, you put these 2 together. When you put them together, you can call it a new letters. You may call this one alpha. So you are going to have the alpha, and the rest of the letters. So the rest of the letters this time is going to be just, you get the 7 letters. Okay, so you fix the first one. You fix the first one, the choices, number of the choices that you have, only 1. Then you go with the other ones. Okay, so you get the alpha here. So for the next choice, here is going to be, because the leftover is going to be just 7 cases that you're going to have. Okay, so the result is going to be, you see, you have 1 choice for the first one. We get to the next one, you have 7 choices, 6 choices, 5, 4, 3, and 1. So the result in this case is going to be 7 factorial. Okay, so you already got the 8 letters. You have to put 2 of them together. So first you pick those 2, you put them together, you put it in the box. You call it alpha. So now you have the alpha and the leftover. So the leftover were 6 letters, and the alpha, then you have 7 letters. Then you are going to rearrange these 7 letters. The number of the rearrangement for the 7 objects is going to be 7 factorial. So this make it different. That would enable us to give you, we have a couple of nice problems. What we would like to do is we would like to combine this idea with what? Remember the addition rule that we talked about it the other day. So there is a combination of the letter of alphabets that we can make to be able to use both problems. Okay, any question? So we need this type of idea to be able to take care of this problem. There are a group of problems similar to what I'm going to do for you. I usually give you one of them on the quiz and one on the final. You see, let's see. It's not difficult, but you have to pay attention when you combine these type of ideas. Remember, there are 26 letters of alphabet. And if you want to arrange them, in different orders, since it's 26, there are 26 factorial to rearrange the letter of the alphabet. Okay, so keep this one in mind. So what's this question? You see, it's an interesting one. We want to know in how many ways, okay, in how many ways can 26 letters of alphabet, letters of the, of course, English alphabet, of the alphabet be arranged English alphabet. That's in English. Okay, be arranged so that none of the pattern none of the patterns, these are the patterns: phone, car, or, okay, Bitly, something like this. Occurs. Okay, that's going to be one. So when we do different combination of the arrangement of the letter of alphabets, you are going to have different words, if you like, different combination. But we would like to find those arrangement that's not going to be containing these 3 words here. Okay, the phone, the car, and the okay, Bitly, if you like. Okay, we want to know how we're going to arrange this type of problems. This type of problems can be solved by using that addition rules that we talked about the other day. Remember the addition one? We talk about the formula. If 3 sets are given to you, A, B, C, then the number of the elements in the union of the A union B union C was what? Inclusive exclusive principle. The number of the elements in each sets, n of A plus n of B and n of C. Then we exclude the 2 by 2 intersections, and we include the total one. But you have to modify that formula first, because when you use the union, I talk about it. When we say A union B union C means if you pick an element, that element X at least is going to be one of those one of those 2 sets, at least one. But the situation is that you don't want them. So you have to make a little bit, We call it the complement type of the addition rule, which is going to be used, in your case. So you have to arrange this problem nicely for us. This is the way we're going to do it for the addition rules, or that complement of the addition rules. So this is how we're going to do it. We need a kind of universal sets for this problem. We talk about the letters of alphabets, okay? So we are interested in arrangements of the letter of alphabet or permutations. It's the same thing. Okay, so what we are going to do, we are going to suppose you have to mathematically design it. I'm going to take U to be all arrangements of the letters of alphabet or all permutation of this. Okay, we have 26 letters. So all the permutation of 26 letters, the number would be 26 factorial if you like, okay? So take U to be all permutation or arrangement. You have to explain it, remember, on the test. This is going to be all arrangement. Okay, all arrangement of what? Of letters of the alphabet that we talk about it. English one. Alphabet. Okay, it's going to be all arrangements of the letters of alphabet. That's U. So what's going to be A? A is going to be all these arrangements containing the form. Okay, containing this one. So A would be all. Okay, it's going to be all arrangements in U, if you like, or arrangements in U, means of the letter alphabet, containing, okay, containing the word form. Okay, that's going to be one. So B would be again all arrangements in U, alphabets containing the word car. Okay, and the C would be the other one, depends how many are you going to have. C is going to be all arrangements in U, all the members in U, all the elements in U, containing this word, okay, MB3. Okay, so this is going to be the case that we're going to have. Now, if you use the addition rule that we talk about it, you just find what? You find the number of the observations or the number of the permutations that's containing A or B or C, and of union of A, B, C. But you don't need that one, or it's not going to be the case because they ask for the none here. You see, look at this one from a set point of view. This is U, universal sets that you have, all the possible permutations. So that formula that we talk about it would give us, you see, suppose this portion over here, this portion over here is going to be A union B union C. So this means all the permutations that contain at least one of these. Then the outside part here, you see this part over here, what's going to be this one? This one would be the complement. It's going to be the complement of the A union B union C complement. So inside the set would contain at least one of these terms, but outside of the set is containing none of these sets. See, that's going to be the version that you are going to be interested in. So what you have to find for us is this one, the outside one. You want to find what's going to be how many permutations are going to be in A union B union C, but complement. You see, complement because they say none. Okay, so this is going to be what you have to find for us. Any question? So some people, they make a mistake. They just go for the A union B union C. It's not. A union B union C, as we did it the other day, would give you a number of the combination that at least contain one of these words. So you need a complement. So what is going to be the complement? The formula, you know that the complement is going to be, so you note that this is it. So the number in the complement is going to be equal to what? The total number minus the numbers in the union. Okay, so it's going to be the complement of this set. The total number in U, the total number of the permutation, minus all the permutation that contain at least one of these words. All the permutation that contains at least one of these words. So you have to have a reformation of the addition rule to be able to do this type of, and they are quite popular one in this type of format. This is the one that you may have to use in future. So it's going to be a kind of a negation of what you usually write. So you have to modify it yourself. You modify it nicely because you have the only format that you have is this one. So you have to modify it so that you'll be able to do it. Okay, any question? Now, if you like, you can write the formula, then you substitute. So you can find the A union B union C, and then come back and substitute here if you like. Or you can do it right away, it doesn't matter. Okay, so what I'm going to do, I'm going to write the new formula for you. So if you like, if you want, it's going to be A union B union C complement is going to be equal to the n of U minus, remember this one? First, we add each sets. So inclusion, exclusion principle. So it's going to be n of A plus n of B plus n of C. So that's going to be negative. Exclude, then plus 2 by 2, n of A intersect B, okay, plus n of A intersect C, plus n of B intersect C. In the other formula is minus, but since there is a negative here, you switch the signs. Okay, so the negative positive, then you have to subtract their intersections. N of A intersect B intersect C to get these numbers. Any question? So I just rewrite that. Okay, I'm rewriting the inclusive exclusive principle or the formula that we talk about it. Since there is a negative sign over here, so I switch the signs. So I start with the actual each set separately. I start with the negative, so that would be positive. Positive the intersection of a 2 by 2 one, and minus the intersection of all of them. Okay, so you have it in this format. In your book, they talk about this new format of this formula in 9.3, in fact, to explain it for you for the complement version. Okay, any question? Now we have to bring these numbers for us, and that's lots of fun to find it. Okay, remember they are all permutations, arrangement, different arrangement of the letter of alphabet. Okay, so let's do it one by one. What is going to be n of U? You see, n of U is all the permutations of a 26 letters of alphabet. We know that. There are 26 factorial. That's it, 26 factorial. So that's the first one. Okay. So let's see what's going to be n of A. n of a. You see what is a? A is all the permutation containing the phone. You see, as I did it for the other problem, this means when you want to make those permutations, so what we're going to do, we are going to form this word for first. Okay, so I'm going among those letters, I'm going to pick this one up. Okay, this is going to be what? This is going to be phone that I'm interested in. So this is a phone. So I make this one. I put it in the box. So these permutations, the rearrangement is going to be rearrangement of the box and all the other letters. Rearrangement of the box and all the other letters. Okay, so I can call this box alpha. So I have alpha and the leftover. So how many letters do I use to form the alpha? You see 1, 2, 3, 4, 5. So I use 5 letters to make the alpha. So I have 26 letters, remember? I have 26 letters. So 5 out of 26, that give me 21. So I have 21 letters and alpha. 21 letters and alpha would be what? Would be 22 letters. So n of a would be what? Would be the total number of the permutation of 26 letters. How many ways you can rearrange 22 letters? And that would be 22 factorial. Any question? So I repeat it again. You want to find all the permutation or the arrangement of the letter of alphabets containing the phone. So what we do, we form the phone first. We form this one first. Each letter is going to be used once. So since you form the phone, 5 letters would be out. 1, 2, 3, 4, 5. So I put this one in the box because you have to fix it. You need this one. I call it alpha. So I have 26 letters. I use 5 here to make the alpha. So 5 out of 26 would be 21. But I have a box. So 21 letters on the box. Make it 22. So the number of the permutation containing the phone is going to be 22 factorials. That's it. Okay, what's the question? So this is going to be the case. Why is 22 instead of 21? So how many letters do we have? You see, the total number of the letters is 26 letters. You take 5 out. 5 out of 26 would be 21. But you have the box. So you get the box and the other letters. So the box is alpha. Alpha is in new letters, and the leftover is 21 letters. So you have 22 letters that you put them together. So that gives you 22 letters. Any question? Because you want to find all the arrangement containing the box. So other than the box, you have 21 letters and the box. So 22 letters. So you get the arrangement of these 22. Okay, now that gives you an idea what's going to be the next one. Okay, so what's going to be the n of b?
24 factorial.
Yes, what was the box? The box is car. So we pick we make a car. So we have to use 3 letters over here, okay? So 3 letters, we may call this one beta. 26, 23, that give you what? Yes, 26, that give you 23, and the beta would be 24, that give you 24 factorial. Any question? You need to pick 3 letters to make the car. So 3 out of 26 would be 23. But you have the box, so it's 24 factorial. Okay, the next one, what is going to be n of c? So what you want to make is bitly. So 1, 2, 3, 4, 5 letters again. So you pick 5 out and you may call this one gamma if you like. So it's going to be like this one. So in that case, you are going to have 22 factorial. Okay, any question? So the combination of 2 by 2, this is tricky. You got to be careful. So let's see. What is going to be n of, okay, what's going to be n of A and B? You see A and B, you want to have these two together. So you're just making the first one. Okay, to make the first one, you're just using, let's just explain this one. Again, I have the box. Okay, I have the alpha, if you like. This is going to be the alpha, and this is going to be the beta that I have. Okay, it's a car and the phone. So you have to form this. To form the alpha, you need 5 letters. To need the beta, you need 3 letters. 5 and 3 would be 8. 8 out of 26 would be 18. It's going to be 18 letters and this new one, alpha and beta. So 18 and 2 would be 20. So that gives you 20 factorial. Okay, so you need to have these two boxes together. So we make the boxes. They are going to be our new letters. The boxes, you get the 5 and the 3 here. 5 and 3, you need 8 letters to make it. But 8 out of 26 would be 18. But you have to consider two boxes. 18 and 2 would be 20, so that gives you 20 factorial. The only thing that you got to be careful is if they share a same letter here. This is the one that you received in your practice one when we posted for you. If they share letter, you see, you can use the letter once. So if you, for example, you use the C here, then you cannot use the C here. So this means this case is not possible. And in that case, the number of the permutation would be 0. So just you have to make sure that there is no shading in between, because it's a one-to-one function. We can use only one letter. Okay, we get to that one, but you have to check when you want to get these combinations. Okay, any question? So similarly, we can get this next one. So A intersects C. So what is A and the C? You see, this is it, A and the C. 5 and 5 would be 10. 10 out of 26 would be 16, but 2 new boxes, 18. So that gives 18 factorial. Okay, 18 factorial, because in this case, you use the A and the C. So you're using alpha and gamma, if you like. So the alpha and the gamma, you get a 5 and 5, 10. 10 out of 26, 16. But we have 2 letters, 18 factorials, okay? Then the next one is the B and the C. BC, this is it. The BC using the beta and the gamma. So 3 and 5 would be 8. 8 out of 26, that gives you 18, but we have 2 new letters. So make it a 20. 20 factorial. Okay, so it's going to be intersection of the 2 by 2. And we have one more, intersection of all of them. So for all of them, again, you have to check to see if it's possible. So you have to have the alpha, beta, and gamma. So there you are. There is no shading between these letters, so it's safe. We can use all of them at the same time. So that's it. 5 and 5, 10. 10 and 3 would be 13. 13 out of 26, that give it 13 again, but we have three letters. 13 and 3 would be 16, so that give you 16 factorial. Okay, any question? So we just write it down. You don't have to evaluate it, but if there is anything, any common, any like terms, we just simplify it. Otherwise, we accept it. So the final answer would be, okay, so this is it. So the final answer is n of, okay, that was the complement that we talked about it. Union B, union C complement. The first one was 26 factorial minus. The single one was 22 factorial. 22 factorial, 24 factorial, 22 factorial, and then it's going to be plus. Okay, plus that was 20 factorial, 18 factorial, and 20 factorial again. And the last one was minus 16 factorial. Okay, you know, these combinations, you can simplify it a little bit. So it's going to be 26 factorial. It's going to be 2 times, okay, it's 2 times 22 factorials. Is it 22 or 21? It's 22. Yes, it's 22. I just read 21 on my notes. Okay, so it's going to be 22 factorials plus 24 factorial. And over here, it's 20 and 20 would be 222 times 20 factorial plus 18 factorial and minus 16 factorial. So that gives you the final answer. We accept it. You know, if you like, you can use your calculator to get it, but it takes quite a while to get those numbers. Okay, so that would be interesting case that you have to consider for this type of numbers. You know, we can this just a little alphabet is easier to handle, but you can have various formats of these type of problems. That had problems that I talked about it the other day, it's going to be used this form of the that so-called inclusive exclusive principles. Okay, to get these numbers. Okay, that's it. Any question? The one that you may have these intersections. What's that? 26 factorial shouldn't multiply by anything, right? No, it's just 26 factorial. Because that's the total number of the permutation of the letter of alphabet. It's just 26 factorial. You see this? This is just a substitution that you have over here. See, for the substitution, it's saying U. So just
yeah, but when you simplified it, you forgot the minus sign, I think.
Did I? Oh, yes, you are right. Thank you. I missed the sign. You are right. Thank you. 26 factorial minus. You are right. 26 factorial minus that number is very good. Okay. I missed that sign. You are right. Okay. So I write the next one, but I have to go. I'm going to do it next time because this is the one on the final review. Okay. So you can think about it. The only side effect that the one you may missed it is if they share anything. Okay, so I write the actual problem and leave it for you to think about it, but we give you the solution. Okay, on Monday when we practice for that quiz. Okay, so that's going to be the one. This would be from a final review, and you have one in your your practice one. Just give you the hint. Look at this one. I gave this one on the test. Some people they miss it. See in how many ways can again 26 letters of alphabet. Okay, letter of the alphabet be arranged. Okay, be arranged so that none of the following. Okay, none of the pattern so the patterns this time are going to be this one, spin. It's going to be spin, game. Okay, game or pat. So that's one occurs. You see the problem about this one, the arrangement is going to be the same, that you're going to arrange it. It would be the same. This is going to be your A, B, C. You see the difficulty is going to be when you put them together, because look at the okay, look at the path, for example, over here. So when we get to the combining these two together, you see the letter A can be used only once. So it's already been used for the game. So we cannot use it for the second one. So if you call it A, B, C, then the number of the permutation that contains the B and the C is going to be 0 because it's not possible. And then it's going to be the same thing for this one. The letter P, you're sharing with the first one and the and the last one here. So in that case, you cannot have that one. And you cannot have the intersection of all three together. So this problem would be much easier. I write the solution for you next time because I have to go a little bit early today. Okay, so this would be on the final review. Some people like, make it nice, but this is going to be the one. But sometimes, that would be enough just to give you an idea. But sometimes, if you have some words like, you see, you have some words like can and the net, you see, they're sharing the same letter, but you can put them together, you see, this is it. You can have something like can and net. Okay, just one end, sorry. So you may consider this one as a combination, if you want to be picky about some of these type of problems. But we just want to know if there's going to be intersection between these two, then you have to be, you have to be careful. Okay, so it's going to be one version, and there is another one that be not the letter of alphabet, something else. We talk about it later. In your book, you have a couple of them related to the, those strings of 0101. You have it, but there is a very good discrete mathematics book. It's written by the author name is Grimaldi, and that was one of those original discrete mathematics book that I used to teach from. That one. It's a very dense one. He likes this type of ideas, so there is one section on this type of interpretations of these type of problems. Okay, that's why I wanted to know it. Okay, that's it. So what we are going to do, I think we stop here. So I will check to see how far we can go. So we may review for that quiz. Okay, on Monday we give you the quiz. I think the quiz is going to be on Wednesday, and then we get to the final week. And this is how much we usually we go for it. Sometimes we talk about the some property of the special graph. It's going to be 3. So we may talk about it if we get times. There are a couple of theorems that we can use induction to prove it, but officially we are done. Okay, that's good. But we review for the quiz and the final to see what's going on. Okay, that's it. Any question? So I will create that one. So we are going to have your last quiz and the last assignment. So I just put them together. Whatever is going to be the leftover of those assignments going to be due. You bring it in, you get your last 10 points, and then we'll be fine. Okay, have a good one, and just check for the practice quiz number 4 and the final review, so you can get the idea of what's going to be on the final. Okay, any question? Have a good day, and see you on Monday. That's it. Bye-bye.
Thank you. See you Monday.
Thanks, Professor.